Hello everyone, welcome to Poesis e-learning and certification services. This is a new video session in the data communication series, and in this session I'm going to share basic concepts related to data communication with you. I will begin with the basic terminologies and definitions. There are two key terms we will always refer back to throughout our discussion: communication and connectivity. Communication is an activity where two persons or two systems engage in the exchange of properly formatted, meaningful messages. Take a note of the word meaningful. Messages have to be meaningful. Connectivity is defined as a physical link connecting two or more systems to each other, and these physical links facilitate exchange of messages. Connectivity is must for communication. Applications running on computers engage in communication activities, and these applications use physical medium or link connecting systems to each other to exchange messages. The set of rules followed by applications to create and understand each other's messages is called protocol. Examples are HTTP, MQTT, and AMQP. Connectivity can be established between systems in two ways: wired and wireless. In case of wired, conductive wires and optical cables are used as medium. Data is encoded as voltages in case of wires and light pulses in case of optical fibers. Wireless, a preferred mode of connectivity, uses RF links as medium. Data is encoded as RF signals of different amplitude, frequencies, or phases. Let us now look at different ways wires can be used to connect systems to each other to exchange binary coded data. In case of digital communication, data is represented using two-state logic or binary encoding. For example, a number 5 is represented as 00000101 in 8-bit format. There are two ways two systems can exchange binary coded messages using wires: serially or parallel. In case of serial communication, data bits are transmitted in a sequence, one bit at a time, using one wire. In case of parallel communication, data bits are transmitted parallelly, all at once, using as many wires as many bits are there in message. So if there were 8 bits in the message, 8 wires would be used. If there were 16 bits in the message, 16 wires would be used. When we compare these two types of communication, parallel communication, though offer better speed, but suffers from interbit synchronization issues and interwire interference issues. Serial communication, because it uses only one wire, doesn't suffer from these issues, and it also allows chip makers to use less number of pins to enable their systems to connect and communicate with each other. Since serial communication is a preferred way of connecting systems and enabling them to talk to each other, let us dive deeper to look at different types of serial communication. There are three types of serial communication: simplex, half duplex, and full duplex. In case of simplex serial communication, only one wire is used as data wire, and data flow is unidirectional. TX here stands for transmission, RX stands for receiving. There is a common electric reference, ground, connecting two systems to each other. In case of half duplex, only one wire is used as data wire. However, the flow of data is bidirectional, means systems can transmit and receive, but not at the same time. They take turns. In case of full duplex serial communication, there are two data wires. Systems can simultaneously transmit and receive data. So the flow is fully bidirectional. Majority of microcontrollers, SoCs, computers, and other electronic systems supports full duplex serial communication. So you always find TX and RX lines on these chips. The role of physical link, medium, or channel is most crucial when it comes to data communication. This is why we have several guidelines, recommendations, and standards to help us choose right medium to connect our systems. The set of guidelines, recommendations, and standards form physical layer protocol. This includes selection criteria of the medium, for example, length of the wires, types of connectors in case of wired communication, frequency bands in case of wireless communication, and so on. Reliability, efficiency, and security are primary considerations in the selection of the medium. I hope you found this information useful. In the next video session, I will cover one of the most popular and simplest serial communication standard, UART, Universal Asynchronous Receiver Transmitter. So stay tuned, stay in touch, happy learning.